this one is a classified sheet which is related to topic one. Topic one, we discuss about the physical quantities, the SI units, errors and uncertainties, and scalar and vector. The learning objective I already mentioned according to Cambridge, but this is same for edXL students as well. So you can use mic, chat, or screen annotation to answer this. The first one, underline all SI base units in the following list. Use screen annotation to answer this. All SI base units. So when we talk about the column is not the base unit, it is a derived unit. SI base unit, anyone? So current is not the unit, current is a quantity. So this is a unit, that is right, but that is not the base, that's a derived. Current is a quantity, not the unit. That's why we did not underline. If it was ampere, yes, we will underline. Then we have Newton is a unit, but it's not the base, it is a derived. So we are left with Kelvin, which is a base unit of temperature, and ampere is there, which is a base unit of electric current. Is it clear? So we just have to underline here ampere and Kelvin. The next one, a toy car moves horizontally. This is related to equation of the motion. That's our next topic. So we'll just skip right now. I can tell the answer, but it does not make difference as we did not discuss anything related to equation of motion, as that's our next topic. We'll move on to 1C. So in 1C1, an experiment is performed to find the acceleration of a car using the following measurements in B. So in B, it was S equal V square over 2A. So S equal V square over 2A. That's the formula we have to use. Calculate the acceleration. So how to work out the acceleration? We have S here and we have V. What is the acceleration? Use a calculator. If you need an acceleration, it will be V square over 2S. What's the answer? Yes. You can annotate on the screen. You can use mic, chat, screen annotation. Anything which is convenient, just write. So 0.98, okay. 0.97, 0.9, 1.94. No, it should not be 1. Because it's V square over 2S. So V is 2.75, so it should be 2.75 square divided by 2A. Divided by 2S, I guess. So it will be 3.89. So 0.97 or 0.98. The next is determine the percentage uncertainty to two significant figures in the acceleration. So how the acceleration is calculated? We calculated the acceleration by using a formula that A is equals to V square over 2S. So the formula which we use, A is equals to V square over 2S. So what will happen? We need the percentage uncertainty in A. So what will the percentage uncertainty in A? the percentage uncertainty in A will be equals to percentage uncertainty in V multiplied by 2. Why multiplied by 2? Because it's V square plus the percentage uncertainty in S. So what's the answer for this? Because this one is V square, the power is there, that's why it will be the uncertainty. The percentage uncertainty in V square will be twice as compared to that of V, and the uncertainty in S is there, and we just simply add them. What's the final answer for this? It is around 2.1%. 2.1%, yeah. Why? Because twice the percentage uncertainty in V, that is because V is 0.8 divided by 2.75 and then multiplied by 100 and then times 2. And the percentage uncertainty in S will be the uncertainty in S 0.5 divided by 3.89 multiplied by 100. And you just simply add them. So the final answer will be 2.1%. So the value of the A was 1.97 and this is 2.1%. And they asked two significant figure, that's why we use 2.1. The next is use your answer to C1 and 2, determine the absolute uncertainty in A. So look, there is a question as one of the student asked, like when we are finding a when we are finding an acceleration, the formula is v square over 2s. Okay, that's the formula we use. So the uncertainty will be twice the percentage uncertainty in v. But why it is written 2s? The question student asked that why we did not multiply the uncertainty of the displacement by 2. What is the reason for that? Because 2 is the fixed number. There is no uncertainty in 2. Like you can 2 cannot be 2.1, 2.2, 2.3, so it does not make difference. That is why we did not multiply this by 2. So 2 is a constant here. Is it clear? So because 2 is a constant, that's why we don't have to multiply with any number. Even if it was written 5s here, I will not multiply it with 5. So the constant, we don't multiply. We just take the exponent. If there was a question like related to this part only, if there was a question and they asked what is, if the simple question was there, what is the uncertainty of 2s? Say S was 3.89 plus minus 0.5%. Okay. And specifically, they specifically asked what is the uncertainty in 2s. So actually, what is 2s? 2s is equals to S plus S. So 2s is equals to S plus S. So uncertainty in S plus the uncertainty in S. In that case, the total uncertainty will be double. But when we are calculating the acceleration here, the acceleration is calculated by a formula v square over 2s. So we actually calculated v and we only calculated s. We did not calculate, like 2 is already a part of the formula. That's why we did not include that when we are calculating the percentage uncertainty. Clear? So if the question was what is the uncertainty in 2s? Yes, it will be double. Like because 2s means s plus s. So uncertainty in s plus uncertainty in s. But the question is what is the uncertainty in A? And A is calculated by v square and s. That's why 2 is excluded from that. Is it clear? Then what is the absolute uncertainty? how to work out the absolute uncertainty. So we calculated the value of the A, it was 1.97 with the uncertainty of 2.1% was there. So we need an absolute number, because if we need absolute uncertainty, the percentage uncertainty is absolute uncertainty divided by value recorded into 100. So the value of the A which we recorded, it was 1.97. That is the value recorded. Uncertainty we don't know. The percentage was 2.1 and multiplied by 100. So we just simplify. 2.1. This was 0.97. Okay, I thought it was 1.9. So this was 0.97, the last one. So we took, you see, we simply multiply 2.1 times 0.97 divided by 100. That will be equals to the absolute uncertainty. Is it clear?